Greetings, young mathematicians. Welcome to Saxon Math, Lesson 94, Probability of Dependent Events. I'm Mr. Pretry, and by now I assume that you know that you should have already done the mental math and are ready to check it. So let's check it. All right, well, looking at A, we have negative 144 divided by negative 6. So we know since we have an even number of negative numbers that we will end up with a positive number. And I can look at this and with my mental math think, well, I know that 12 times 12 is 144. So really, since we're dividing this by 6, I can kind of just say 12, and since 6 is half of 12, 12 times 2 is 24. Is the answer to A. Mental math. Order of operations and exponents. This is also pretty mentally math simple because I know that 1 5/10 is really like 1 1/2, and I know that half of 4 is 2, so it's really like 4 plus 2 is 6 times 10 to the negative 8th power plus positive 3rd power will get us negative 5. So 6 times 10 to the power of negative 5. Algebra! So subtracting 1 5/10 from each side. Pretty simple. That just gets us 3. We divide each part of that by 5. So 3 divided by 5. And if you're wondering, can 3/5 be an answer? Nah, because then we're converting from decimals. So no groups of 5 and 3, but there are 6 groups in 30, getting us 6/10 as our answer for C. Measurement. There's a simple rule to remember with converting Celsius to Fahrenheit. It's multiply by 1.8, then add 32. Yep. So really, this works. Here we're going from right to left. And really, I could do this as 3 times 18, dividing the 3 by 10 and multiplying the 1 8/10 by 10. Gets me 52 for this part, or excuse me, 54 for this part, plus 32. Gets, sorry, let me clear all this out of the way. Gets us 86 degrees Fahrenheit. Calculation. 6 times 2/3. Well, 6 times 6 times 2 is 12. And 2/3 of 6 is 4. It's a 16. 10% more than 50. 1/10 of 50 is 5. 5 plus 50 is 55. I know some of you might be insulted right now by such a simple problem. It's okay. Most things in this lesson are going to be pretty simple. Name the transformation that turns a figure, doing geometry, around on a point. So, if you have a figure and you want to rotate it, well, that's it. We call it rotation. So this one actually kind of makes a lot of sense in our regular English vernacular. You're just rotating it. So it's rotation. And H, calculation. 25% is 1/4, and 1/4 of 40 is 10. Times 4 is 40. Plus 2 is 42. Divided by 6 is 7. Times 9 is 63. Plus 1 is 64. Square root of 64 is 8. 8 times 3 is 24. 24 plus 1 is 25. And the square root of 25 is 5. For your answer. Okay, so let's talk about today's lesson. Probability of dependent events. So this first figure is more like what we've done in the past, where we are figuring out the probability of events, but say with this first example, it's two different things that are both happening, but they don't affect each other in any other way than the chances of both of these things kind of happening congruently, sort of at the same time, but they don't actually affect each other. So before we've said, like, what are the chances of drawing a yellow marble and spinning a 4? So, but these things do not affect each other. So we'd say these are independent of each other. These are independent events that we are still trying to figure out what the chances of these both happening are, but they do not affect each other. But this is not what today's lesson is about. Today's lesson is about a situation like this, where we start out with a ratio of marbles, but then an event happens, and this event affects the probability of a second event. So in this case, say you started out with a 2 in 5 chance of drawing a blue marble. But depending on whether you draw a blue or a red marble, it affects the second event. Because if you drew the blue, then you go from a 2 in 5 chance to a 1 in 4 chance. And if you drew the red, then it turns from a 2 in 5 chance to a 2 in 4 chance. So since these things affect each other, these are called dependent events. As in, what happens here is dependent on what exactly happens here in this event. So these are dependent events. So let's see how that looks like in our examples. And I already did a little bit of diagramming for this one. So, example 1, 2 red marbles, 3 white marbles, and 4 blue marbles are in a bag. So I put that over here. So we've got our red, got 2, white we've got 3, blue we've got 4, and all those add up to a total of 9. If one marble is drawn and not replaced, and a second marble is drawn, what is the probability that both marbles will be red? So to start out with, looking at this, we can see that there are 2 red marbles and the total number in the bag is 9. So our first event, we have a 2 in 9 chance that it will be a red marble. However, the second event, everything has changed. Because now, say, if you have successfully drawn your first marble and are going for your marble drawing boss level, then your second drawing, there will only be 1 red marble. Everything else stays the same, except for your total, which is also missing the red marble. So your second chance is a 1 in 8. So now the question is, what is our chance of, after the second event, us having 2 red marbles? So just as a little review, I stashed these guys down here. Just so they wouldn't confuse. This is not part of this problem, but remember, say you were trying to flip 2 heads in a row with coins. So your first chance, you have a 1 in 2 chance, and your second chance, you have the same chance, but in order to, the chance of you actually rolling 2 in a row, you multiply each of the ratios. So you really have a 1 in 4 chance of getting 2 heads. So same thing with this, is we are going to multiply our 2 probabilities. You do a little cross-canceling goodness. And that will get us, 1 times 1 is 1. And 9 times 4 is 36. So the answer is that there is a 1 in 36 chance of drawing two red marbles in a row from the bag. Pretty basic, right? Example 2. 2 cards are drawn from a regular shuffle deck. What is the probability of drawing 2 aces? Okay, well, so starting out, there are 4 aces in a deck of 52 cards. And then after you have drawn one of those aces, then going for your bonus round, both the ace that you've taken and the total, both of those have changed. So that would get you a second ratio. Why on earth did I do that? Of 3 in 51. But you know, who wants to deal with numbers like this when you don't have to? And, you know, if we can reduce the first drawing, we can reduce this fraction to 1/13 by dividing the top and the bottom by 4. And then we can multiply that by, we can divide both these sides by 3. I think the math makers wanted to kind of make this easy on us, I think. And so that can get us a 1 in 17 chance. So multiplying those two sides, 1 times 1 is 1. And spoilers, 13 times 17 is 221. So our chances of drawing 2 aces in a row are 1 in 221. Or like a little bit less than 0.5%. Okay, and that is today's lesson. And in fact, it looks like the problem set, which you should do, is pretty basic. I might need to add something to this, but definitely do this and meet up with me later in the day to go over it. All right, well, thank you very much for sitting through my demonstration, and you have a wonderful day.